Hello everyone! Today we're continuing our discussion on set theory fundamentals. So before we had videos on things such as what is a set, subsets, elements, etc. Today what we're going to be focusing on is a collection of other things, starting with what is known as set builder notation. Right? Set builder notation. It's incredibly important, and you're going to see it a lot of times, and a lot of people get very confused. So it's important to understand what exactly these sorts of things mean. So starting with our example that we have here, set builder notation is a way of defining sets in a very compact and organized way so that when you're looking at it, you can just read and understand and not have to write out all these dots and all sorts of stuff like that. It gets very tiring to write out by hand, trust me. What does this set mean? Well, we're defining a set up here. We're defining a set. We're going to create a set S. And set S is a set, right? That's what the curly braces mean. And it's consists of a bunch of X's, a bunch of things. And what are these things that are inside of this set that we have? Well, it's an X, and then this little bar right here, this means such that. Actually, you know what? Let's write this out in English. S is a set of elements X, so that's up to here. S is a set, is equal to the set of elements X such that, that's what this bar means, such that, and I'll even add the little symbol that tells us what this means. So set is from this curly brace, elements X, that's the X, such that, that's the bar, such that X is less than 0, and X is a member of, remember, that's what this symbol means, right here, of integers. So what does this actually mean? Well, so we have a set consisting of integers that are less than 0. So we need both conditions to be satisfied. That's what and means. X has to be less than 0, and X has to be an integer. So let's start writing out things that would be inside of S. Well, -1. -1, that's less than 0, and that's an integer. So -1 is 0, less than 0. No, it's not, so 0 is not. What about -1/2? Well, that's less than 0, yes, but it's not an integer, so no. How about -2? Yes, -2 is less than 0 and an integer. And this should make sense. -3, -4, ... Now let's go through an example of set builder notation. So let's create a set of all squares. So if we were writing this out by hand, right, we would do it like this. We would say like 1 is a square number, and then 4, and then 9, and then 25, and ... But this is lame. This is such a boring way of writing it. Let's do it in a cool, kind of slick way of writing it. So how do we write this in terms of our set builder notation? Well, we could do it this way. We could say we want a set S contained of elements X such that X is a square number. I mean, you could, in theory, do this. I feel like this is kind of cheating because it's so verbose. Or, what if we were to do this? Let's say S is a set of x squared such that x is a natural number. I think that was an awful curly brace. Oh, I can't really save that. Okay, good enough. Now what we do is we have elements squared such that it's in the natural numbers. So this is going to be 1, 2, 3, 4, dot, 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 dot. So for every natural number, we take it and we square it, and that's what is inside of our set S. With that, that's all you really need to know about set builder notation. You just need to understand that this right here is what goes inside of the set, and this is the condition of what x's are allowed to be used here. And with that, you know what you need to know.